Hello students. So let us today learn what is polarization of light. Okay. So for that, first let us consider the two field vectors of light. Light is an electromagnetic wave, so that is why it has one electric field vector and one magnetic field vector, and they are oriented in this manner that if the direction of propagation is this way, electric field vector will be in this way, magnetic field vector will be in this way, and all are perpendicular to each other. That means the plane containing E vector and B vector will be always perpendicular to the direction of propagation. Okay, so this is the basic nature of light, and this electric field vector is important for us while discussing polarization and all, because this is known as the light vector, and because it is responsible for the sensation of light, and also since electric field vector and magnetic field vector, they are lying on the same plane, so it does not matter if we consider only one of them. So ideally we consider only the electric field vector as the vibration, for the vibration of light, denoting the vibrations of light. Okay, so now let us come to the idea of unpolarized light. So if we have a source and light beam is coming out of it, so it has all possible directions of vibration for the electric field, like this. That is called unpolarized light, and actually it is like this. That means the electric field vector will be this way, also in this way, because it is in the form of a beam. So all possible vectors or directions are there. So this way we have all possible directions. So this is actually represented symbolically like this. That means the electric field vectors are having all possible orientations, but it is perpendicular to the direction of propagation. And correspondingly we have the magnetic field vector also, but that we are not considering for now. Okay, so we are considering these directions as the direction for the electric field vector, and these are denoting the vibrations. Now suppose if we draw the electric field vector like this, so this is vertically up and down direction. If it is like this, so it is like inclined like this. So these are all possible directions of electric field vector. Okay, all the possible orientations. That means this will be denoted like this, this will be denoted like this, and so on. So in unpolarized light we have all possible kinds of this kind of vibrations for electric field. So that is why unpolarized light is something like this, all possible vibrations. I think this is clear to you. So this is unpolarized light. Now let us come to the polarized light. Now what is polarized light? If you have unpolarized light and if you put some medium in between which is capable of restricting all other components except one, then the resultant light will be plane polarized. The vibration will be restricted to only one particular plane. That means if we have original something like this, then after it is passing through this medium called polarizer, and polarized light is passing through this polarizer, and we will be discussing what is polarizer later on. Then what happens? Vibrations are restricted to one plane. That means originally we had this, then after passing through the polarizer it becomes something like this. Only one component, only one direction of vibration will be left out. So this is plane polarized light, this is unpolarized light. Okay, and what is this polarizer? Polarizer is anything which is capable of cutting off all other components except one particular direction of vibration, right? So polarizer is naturally seen in case of glass also. If you have one ordinary glass slab, and if your angle of incidence is such that, call it IP suppose, such that the reflected and transmitted if they are at 90 degrees to each other, then it is seen that if this was originally unpolarized, then this is plane polarized, this is also plane polarized. The difference is that here the vibrations of the two will be at right angles to each other. If this is into the plane of paper, then this will be parallel to the plane of paper. Okay, so this particular condition is called Brewster's law. So that this means that if the angle of incidence is such that the angle between this reflected and transmitted ray is 90 degree, then this condition is satisfied. Sine of 90 minus IP, so that it is tan of IP. So this is called, oh sorry, this is not IP, this is mu. So this is called Brewster's law. So refractive index of the medium is equal to sine of angle of incidence divided by sine of angle of refraction, so that mu is equal to tan of IP. Okay, this is obtained naturally. That means plane polarized lights are obtained naturally by one glass slab in this way for a particular angle of incidence IP. Okay, so there are some natural polarizers like some crystals, calcite, quartz, tourmaline, etc., which are capable of naturally restricting the different vibrations of light, and only one the component or sometimes more will be allowed to pass to the other side of the medium. So those we'll be discussing in some other class. Okay.